Alright, let's continue. Dito na tayo sa NFP or net filtration pressure, which is the overall pressure that determines whether fluid will be filtered out of the glomerular capillaries into the glomerular capsule, which is influenced by three main pressures. So we have GBHP or the glomerular blood hydrostatic pressure, which is the pressure within the glomerular capillaries. No? Yung GBHP kasi pushes water and solutes in the blood plasma through the filtration membrane. It drives the filtration process. Sa CHP naman, or the capsular hydrostatic pressure, yun yung pressure exerted by the fluids already present in the capsular space and the renal tubule. So it opposes filtration. No? Nag-create yan ng back pressure that resists movement of fluid from the glomerulus into the capsule. Meron din type BCOP or blood colloid osmotic pressure. Yan yung pressure na ginawa or created by the presence of plasma proteins kagaya ng albumin, globulin, and fibrinogen na nasa blood. So sa BCOP naman, it tends to pull water back into the glomerular capillaries. So kindly read on the calculation of NFP. Nandyan yan sa Tortora. Let's discuss GFR. Pag sinabi natin GFR, this is what we call the glomerular filtration rate, and this refers to the volume of filtrate formed by all the renal corpuscles in both kidneys per minute. So sa adults, the average GFR is 125 ml per minute in males and 105 ml per minute in females. No? Ang GFR kasi crucial parameter yan para ma-maintain natin yung homeostasis ng body fluids. No? Para ma-ensure natin dito na yung kidneys kaya niya mag-filter ng enough plasma to regulate the body's fluid and electrolyte balance. So, kailangan natin ng proper GFR control dito. Kasi if masyadong mataas ang GFR, yung mga substances, pwedeng mabilisan lang yan na dumaan. No? Pwedeng mag-pass too quickly lang yan sa mga renal tubules. No? Ay possible na insufficient ang reabsorption natin kasi masyadong mabilis yung pagdaan nila. Yung important substances, hindi na natin nare-reabsorb. Ibig sabihin, no, naiihi na lang sa urine. Sa GFR naman, kapag masyadong mababa, yung mga filtrate natin mare-reabsorb, yung mga nutrients. Pero possible na mag-accumulate naman yung mga waste products, hindi natin ma-excrete ng maayos. So, kindly read on the regulation of GFR. Dito tayo sa tubular reabsorption and tubular secretion. Okay? Now, tubular reabsorption muna tayo. Basically, pag sinabi natin na tubular reabsorption, dito nagre-return tayo ng useful substances pabalik sa blood. Alright, now, most of the filtered substances ay nare-reabsorb. No? Majority ng reabsorption nangyayari sa PCT or the proximal convoluted tubule. So, ano ba yung nare-reabsorb doon? No? 99% ng water nare-reabsorb back into the bloodstream. Yung mga solutes naman, kagaya ng glucose, amino acids, urea, mga ions kagaya ng sodium, potassium, calcium chloride, bicarbonate, phosphate, nare-reabsorb din. Which is also vital sa processes ng katawan mo. Hindi mo dapat yun naiihi lang lahat. So, paano ba yung reabsorption? Paano yun nangyayari? Ang reabsorption kasi possible na active or passive. Pag active, kailangan ng energy. Pag passive, hindi kailangan ng energy. So, pag-usapan muna natin sa PCT. No? Sa PCT naman, major site yan kung saan nagkakaroon ng active reabsorption. Meron kasi tayong transporters doon na nagmo-move ng solutes from the filtrate into the cells. And the solutes move into the surrounding blood vessels, no? Mga peritubular capillaries. Sa tubular secretion naman tayo. Pag sinabi natin na tubular secretion, dito tayo nag-get rid of wastes, no? The second major process is the tubular secretion. Okay, move na tayo doon. Para tayong nag-take out ng trash. No? Ang focus kasi ng reabsorption to bring back useful stuff. Pero pag sinabi natin secretion, move things from the blood into the filtrate para ma-excrete as urine. Is that clear? Dapat clear yun, ha? So, ano yung mga nasa-secrete natin? Hydrogen ions, no? Potassium, ammonium ions, creatinine, even drugs. Na-excrete natin yung mga yan. So, dito tayo sa reabsorption routes, no? Yung mga path ng substances. Kasi dalawa yan. Meron tayong paracellular at saka transcellular. Pag sinabi natin paracellular, yung mga substances, naglilik lang yan between the cells, no? Na nakikita din natin sa PCT or the proximal convoluted tubule. Kasi yung mga junctions doon, medyo leaky. So, ibig sabihin nun, kayang dumaan-daan doon ng mga ions, mga water, no, from the cell or between the cell into the surrounding blood vessels. Meron din tayong transcellular. Yung pag sinabi natin transcellular, mga substances, it moves through the cell. No? Yung mga substances, again, move through the cell. Now, tingnan natin yung transport mechanisms, kung paano nag-move yung mga substances. Again, meron tayong active transport, secondary active transport, and transport maximum. So, pag sinabi natin na active transport, yun yung kailangan ng energy. Example with the sodium-potassium pump. Pag sinabi naman natin na secondary active transport, gumagamit yan ng energy stored in the electrochemical gradient of ions, no? Kagaya ng sodium, to drive the reabsorption of other substances. Meron din tayong tinatawag na transport maximum. No, pag sinabi natin transport maximum, kasi isipin nyo para siyang conveyor belt. No, kaya niya lang mag-handle so many items at once. May limit siya kung ano yung kaya niyang makarry. Kapag kasi, basically kapag sinabi natin transport mechanism, yun yung highest rate at which a substance can be reabsorbed. So, nami-measure natin ang TM in milligrams per minute. So, dito tayo sa water reabsorption. Meron tayong dalawa, obligatory and facultative. So, pag sinabi natin na obligatory, no, this happens when water is reabsorbed along with solutes, kagaya ng sodium, chloride, and glucose. So, around 90% ng filtered water ay nare-reabsorb sa ganitong paraan, mostly in the PCT or the proximal convoluted tubule and the descending limb of nephron loop or loop of Henle. Meron din tayong facultative water reabsorption. More on optional na to, mga 10% ng water na re-reabsorb dito sa ganitong paraan. Now, this is regulated by ADH or the antidiuretic hormone and occurs in the collecting duct. So, kapag kailangan ng katawan mo mag-conserve ng water, example ay na-dehydrate ka, yung ADH naman, it makes the collecting duct more permeable to water. No, ibig sabihin nun, more water gets reabsorbed into the bloodstream. So, tingnan natin yung glucosuria sa clinical connection. No, pag sinabi natin glucosuria kasi, it happens when there's too much glucose in the blood for the kidneys to reabsorb. Typically kasi, kapag mataas na or more than 200 mg per ml na ang glucose natin, hindi na kaya ng mga transporters yun. Hindi niya kaya mag-keep up. Ibig sabihin nun, nagli-leak or natatapon ng glucose sa urine. So, isa sa pinaka-common cause ng glucosuria ay diabetes mellitus. Yung insulin hindi nagpo-function properly kaya ang taas-taas ng glucose levels niya. So, ano na ngayon nangyayari sa katawan ng isang may diabetes mellitus? Say for example, yung glucose kasi, nagpupul siya yung glucose sa urine nagpupul siya ng water with it. Kasi ang glucose ay osmotic. Ibig sabihin nun, kapag pinul ng glucose yung water with it sa may urine, naglilid yun sa polyuria. Ibig sabihin nun, there is excessive urination. Nagkukos din yan ng dehydration. So, in here, the body loses both water and glucose. Kaya nagkakaroon ng lower blood pressure and electrolyte imbalance. Okay. Dito naman tayo sa reabsorption and secretion in the PCT or proximal convoluted tubule. No? Again, it plays a big role in reabsorption of solute and secretion of waste products. So, tingnan muna natin yung solute reabsorption sa PCT. 100% ng filtered glucose, amino acid, mga organic solutes natin, nare-reabsorb sila. 50% of filtered chloride, urea, variable amounts of calcium, magnesium, and phosphate are also reabsorbed. Now, when it comes to sodium transport mechanisms, meron tayong sodium importers dito. No? Yung sodium is reabsorbed using secondary active transport mechanisms. Now, these importers couple the movement of sodium with other solutes, kagaya ng glucose, amino acids, and phosphate across the apical membrane into the renal tubule cells. So, say for example, yung sodium glucose importer. Meron tayong dalawang sodium ion and one glucose molecule na natatransport into the cell. Once inside the cell, yung glucose mag-exit via facilitated diffusion. Mag-enter ngayon yon sa peritubular capillaries for absorption into the bloodstream. No, meron din tayong sodium hydrogen antiporters. No? Next, meron tayong water reabsorption and osmosis. No? Sa PCT kasi, yung water dyan nare-reabsorb passively via two routes. Meron tayong paracellular and transcellular. Pag sinabi natin paracellular, yung water nag-move yan between the cells through gaps or tight junctions. Pag sinabi naman natin na transcellular, the water moves through the cell via water channels, also known as your aquaporins. Ang PCT nyo kasi, maraming aquaporin 1 channels yan. Okay, now dito tayo sa ion and solute movement. No? Ion and solute movement naman tayo. Now, yung mga ions kanina na nabanggit natin, they move back into the blood via paracellular and transcellular routes. Now, yung chloride natin, yung pinaka-abundant, it diffuses through the paracellular route. Now, as chloride moves, it makes the interstitial fluid negatively charged, which then attracts positively charged ions kagaya ng potassium, calcium, and magnesium back into the bloodstream. Now, example yan ng electrochemical gradient. Next one would be ammonia and urea secretion. No? Kasi ang ammonia and urea, toxic products yan from metabolism of proteins. Kailangan natin yung i-excrete. So, unahin natin si ammonia. Ang ammonia kasi, mainly it produce yan ng liver, but it's also generated by the PCT via glutamine metabolism. Ang ammonia kasi, nagbabind yan quickly with hydrogen ions para mag-form ng ammonium na masesecrete into the tubular fluid. Now, yung bicarbonate na na-generate sa reaction na to, babalik or pupunta sa may bloodstream, acting as a buffer para ma-maintain natin yung blood pH. Now, pag sinabi natin urea kasi, it is filtered by the glucose. No? Masesecrete yan into the PCT. Okay? Now, dito tayo sa reabsorption in the nephron loop. No? Also known as the loop of Henle. Now, tingnan natin yung fluid flow muna. No? Kunwari natapos na siya sa PCT, pupunta na yan sa may nephron loop. No? Dito, iba na yung composition ng filtrate kasi wala na yung glucose, amino acids na reabsorb na yon sa naunang tubule. So, tingnan natin yung reabsorption in nephron loop. Recall natin na yung descending limb, no, more on water reabsorption. Na yung ascending limb, particularly the thick ascending limb, solute reabsorption na yan. No, kagaya ng sodium, potassium chloride ions. Now, dito tayo sa reabsorption in the early distal convoluted tubule. No, meron siyang role sa fine-tuning of fluid and electrolyte balance. So, water reabsorption tayo around 10 to 15%. No, medyo nare-reabsorb dito via osmosis. Meron din tayong sodium and chloride reabsorption. Meron din calcium reabsorption. No? Yung PTH kasi, it increases calcium reabsorption sa DCT, adjusting calcium levels according to the body needs. So, yung amount kasi ng calcium reabsorption sa DCT variable yan, depende sa calcium requirements ng katawan mo at depende din yan sa action ng PTH. Dito naman tayo sa reabsorption and secretion in the late distal convoluted tubule and the collecting duct. Okay. Dito naman nagkakaroon na ng fine-tuning. So, fine-tuning na lang dito at konting adjustments na lang dito. And this is influenced by hormones kagaya ng aldosterone and ADH or an antidiuretic hormone. Meron tayong two primary cells na merong role. Meron tayong principal cells and intercalated cells. So, discuss muna natin yung principal cells. And meron siyang main function, which is sodium reabsorption and potassium secretion. Ang sodium kasi, nag-enter yan ng principal cells through sodium leakage channel sa may apical membrane. Meron din tayong sodium-potassium pump na nagtatransport ng sodium out of the cell into the interstitial fluid para mababa yung intracellular sodium concentration. Now, yung sodium naman magdi-diffuse passively from the interstitial fluid into the peritubular capillaries para makomplete yung reabsorption. Again, meron din yung potassium secretion. No? Meron tayong potassium leakage channels, both sa apical and basolateral membranes. No? Okay, dito tayo sa hormonal regulation. The first one would be aldosterone. Yung hormone na to, ini-enhance niya yung sodium reabsorption and potassium secretion kasi ini-increase niya yung activity ng sodium-potassium pumps. And ADH naman. ADH, known as your antidiuretic hormone, increases water reabsorption via aquaporin channels. Next would be intercalated cells. Ang main function yan would be pH regulation kasi nagre-reabsorb yan ng bicarbonate, nagsasecrete yan ng hydrogen. Now, dito tayo sa regulation of water and solute reabsorption. No? Now, yung amount of water na nare-reabsorb sa late DCT and collecting duct would be depending on the body's hydration status na nire-regulate ng ADH. Kapag meron kasing ADH, nag-insert yan ng aquaporin channel sa membrane ng principal cells. Kapag merong aquaporin channel, mas tumataas ang permeability ng water permeability. No? Therefore, nagkakaroon ng enhancement as well ng water reabsorption back into the bloodstream. Now, dito naman tayo sa solute reabsorption and secretion. No? Nandyan yung aldosterone and ADH na madidiscuss natin mamaya. Next one would be the homeostatic regulation of tubular reabsorption and secretion. Andyan yung angiotensin 2, aldosterone, ADH, ANP, no, PTH. Discuss natin yan isa-isa. So, dito muna tayo sa RAAS, no? So, ano bang nagtitrigger sa RAAS or renin-angiotensin-aldosterone system? No, na-activate yan kapag mababa yung blood volume o kaya naman mababa yung blood pressure, which happens kapag kunwari may dehydration, may blood loss, may decrease sa sodium levels. So kapag bumaba ang blood volume or yung blood pressure, yung mga arterioles, specifically your afferent arterioles, hindi masyadong nagsistretch. Yung lack of stretch na yun, madedetect ng specialized cells called your juxtaglomerular cells na nakolocate dyan sa kidneys natin. Now, yung sympathetic nervous system din, yung nag-fight or flight response, kaya din niyang mag-stimulate, no? I-stimulate niya yung juxtaglomerular cells to release renin into the bloodstream. Ano ngayon yung role ng renin? Pag kunwari na-release na yung renin, by the way, ang renin kasi enzyme yan na nagsa-start ng chain reaction. So, kunwari na-release si renin, it first acts on a protein called angiotensinogen, no? Which is made by the liver and it is also always present in the bloodstream. Yung renin na yan, i-clip off niya ang 10 amino acid portion ng angiotensinogen para makagawa ng new molecule. Yung tinatawag natin angiotensin 1. Yung angiotensin 1 by itself, hindi siya active. Kaya kailangan natin siya i-convert sa active version. No? Kailangan natin siya i-convert into angiotensin 2. So, nako-convert lang yan through an enzyme called ACE, yung angiotensin converting enzyme, which is found in the lungs, possible sa other blood vessels as well. So, paano nag-work yung angiotensin 2, yung active version? Meron siyang 3 primary actions sa kidneys and of course the rest of the body para ma-restore yung blood volume and blood pressure. The first one would be vasoconstriction ng afferent arterioles. Yung angiotensin 2 kasi, no, i-cause niya yung afferent arterioles to tighten or to constrict. Nung pag na-constrict na yun, marireduce yung amount of blood na papasok sa may glomerulus. Ultimately, bababa ang glomerular filtration rate. Ibig sabihin nun, less blood is filtered through the kidneys. Bakit important yun? Kasi kapag na-reduce natin ang glomerular filtration rate, the kidneys filter less fluid. No? Nakaka-conserve tayo dito ng water. Mariretain natin yung blood volume kapag mababa ang blood pressure. Okay? Number 2 naman, it enhances reabsorption of sodium and water in the PCT. So, anong nangyayari doon? Sa PCT kasi, yung angiotensin 2 is-stimulate yung activity ng sodium-hydrogen antiporters. Yung antiporters kasi na yun yung nag-exchange ng sodium ions for hydrogen ions. So, why is this important? Ang sodium kasi kapag na-reabsorb back into the bloodstream, susunod yung water. Okay? Again, susunod yung water sa sodium through osmosis. Yung water din mare-reabsorb together with your sodium. This process helps increase blood volume and in turn, tataas din ang blood pressure. Okay? Now, number 3, it stimulates aldosterone release from the adrenal cortex. So, anong nangyayari dito? Si angiotensin 2, sinestimulate niya si adrenal cortex na mag-release ng hormone called aldosterone. Yung aldosterone na yon mag-a-act sa principal cells sa collecting ducts ng mga nephrons mo. So, paano yun nag-work? Si aldosterone, ipapromote niya yung reabsorption of sodium from the filtrate back into the bloodstream. And at the same time, isa-stimulate din niya yung secretion of potassium into the tubular fluid para ma-excrete sa urine. Now, because sodium reabsorption brings water with it, kasi nga sa osmosis, mas marami ding water na marireabsorb, leading to an increase in blood volume and increase in blood pressure. Now, tingnan natin itong ADH or antidiuretic hormone, which is released from the posterior pituitary and it also plays a role in facultative water absorption sa kidneys mo. Now, ADH works by increasing the permeability of the principal cells in the late distal convoluted tubule and your collecting ducts. No, tingnan natin yung mechanism of action ng antidiuretic hormone. Now, the first one would be ADH secretion and action. So, yung ADH kasi, it is secreted when there is an increase in plasma osmolarity, possible due to dehydration or low water intake, or kapag bumaba yung blood volume. Say for example, mayroong hemorrhage, mayroong severe dehydration. Now, yung ADH magbabind yan sa receptors on the principal cells. No, nakikita natin sa late distal convoluted tubule and collecting duct. Yung ADH naman, ipopromote yung insertion of aquaporin 2 channels into the apical membrane sa mga cells na yon para mag-increase din ang water permeability ng mga membranes para yung water kayang mag-move from the tubular fluid into the cells. Once nasa loob na ng cells, yung water naman magdi-diffuse across the basolateral membrane, mag-enter yan sa bloodstream, kaya tataas ang blood volume, tataas ang blood pressure. Kapag wala kang ADH, yung principal cells mo, very low water permeability. So, konti lang ang water na marireabsorb from the tubular fluid. Ibig sabihin nun, mas marami kang maiihi. Large volumes of dilute urine ang magagawa mo. Tingnan natin ngayon ang ADH and water reabsorption under different hydration conditions. So, say for example, kapag normal hydration ka naman, ibig sabihin nun, adequately hydrated ka, normal lang din ang ADH levels mo. Kapag dehydrated ka, no, ibig sabihin nun, kailangan mo ng mas maraming ADH para makapag-promote yun ng water reabsorption. Okay? Yung urine mo dito, highly concentrated, hyperosmotic kasi nga less ang water. Kasi nagko-conserve tayo dito ng fluids. So, for example, kapag overhydrated ka, yung ADH dito bababa. So, dito, yung kidneys mo mag-excrete yan ng large amounts of dilute urine, sorry. No, tingnan natin yung mga clinical considerations dito. We have here diabetes insipidus. No? Wala kasi silang ADH or failure of the kidneys to respond to ADH. Possible na mag-lead yan sa excessive excretion of dilute urine. No? It causes severe dehydration and electrolyte imbalance. Okay, dito naman tayo sa ANP. Ayan. Now, ANP is what we call as atrial natriuretic peptide, which is a hormone released by the heart, specifically from the atria. No? Pag sinabi natin atria, yan yung upper chambers of the heart. Kapag masyadong marami ang blood volume mo kasi, for example, ang dami mong ininom, yung ANP mare-release as a response to help bring things back to balance. So, paano ba nare-release ang ANP? Nare-release yan from the atrial cells of the heart kapag mataas ang blood volume or mataas ang blood pressure. And again, it happens for several reasons. Possible may fluid overload or nagkaroon lang ng increased blood return to the heart. So, yung kapag kunwari nag-stretch yung atrial walls kasi nga madaming blood volume, signal yan para mag-release ng ANP. So, once na-release yung ANP, magta-travel yan sa bloodstream, tas ma-reach siya sa kidneys. So, in the kidneys, meron tayong PCT and CT. Kasi ang PCT natin and CD, collecting duct, normally nagre-reabsorb yan ng sodium and water back into the blood. Si ANP, ini-inhibit niya yung sodium reabsorption in both of these parts of the nephron. Iboblock din niya yung sodium reabsorption, di ba blinak niya yung sodium reabsorption? Now, yung ANP causes more sodium to stay in the urine. No, kasi nga, water follows sodium, yung water, mas magsistay din siya sa urine as well. Now, important yan because less sodium and water absorption means that there will be less fluid in the blood. No? It ultimately lowers blood volume. Ano pa yung ginagawa ng ANP? Nagkakaroon din ng inhibition of aldosterone and ADH secretion. Ang aldosterone kasi kapag active, normally ini-increase niya yung sodium reabsorption sa kidneys para ma-retain yung water, para mag-increase ang blood volume. No? Again, ADH increases water absorption in the collecting duct. By inhibiting both aldosterone and ADH, ANP ensures na yung kidneys natin hindi nag-hold on too much water or sodium. Kaya bumababa yung blood volume, nabababa din yung blood pressure. Okay, we also have here parathyroid hormone. So, nare-release ang parathyroid hormone kapag mababa ang calcium levels natin sa dugo. So, anong ginagawa ng PTH? No? It acts on the early distal convoluted tubules ng kidneys natin. It inhibits the reabsorption of phosphate in the PCT and promotes phosphate excretion sa urine. So, nagkakaroon dito ng balance between calcium and phosphate, which is vital for bone health and many biochemical processes. Of course, we also have your angiotensin 2, aldosterone, ADH, ANP, na-discuss na natin yan lahat.